In this video we will create some basic shapes with SVG markup, and following that we'll also learn how to create those same shapes with JointJS. The aim of this exercise is to show you that anything created with SVG markup can also be created with JointJS. Later we look into creating some more complicated shapes and decisions that might influence how you define the structure of your shape. We'll also provide you with some useful tips on useful features along the way, so let's get started. First of all, we will define a simple shape in SVG markup in order to make ourselves more familiar with SVG and the SVG attributes that are available to us. If you're not familiar with SVG, no need to worry. MDN provides this great SVG attribute reference that lists all of the SVG attributes that are available to us. And this link will be available in the video description, so you can find it there. So now it's finally time to write some code. So on screen you can see our code editor on the left, and on the right we have our window with a live preview, so we can see updates visually as we are adding or removing some more code. The first element we are going to create is a simple rectangle shape that has a label in the center. This should be a nice starting point, so let's see how we can go about this. The first element we will create is the group element. So the group element is represented by the G tag. You can think of the group element kind of like the div of SVG. So if you want to group some sub-elements together, move them together, or animate them together, you can use this group element. So as we are creating a rectangle with some text in the center, we will create those sub-elements now. So first we create a rect tag, and then we can create our text tag too. So when we save our file, you will see an update on the live preview. The default fill color of SVG is black, so that's why we can see this color here. First we will focus on the attributes of our rect element, so we will reduce the width and height of our rect to 50. Then we will focus on two attributes that you will become very familiar with using SVG, and that is fill and stroke. So first we will give our rectangle a fill of white, and then we will give it a stroke of black. So when we save our file, you can see the updated SVG in the live preview. Now we can focus on the text attributes. So first we need to supply some placeholder text, so we will provide the text shape. If we save the file, you can see that something has updated on the live preview, but the position of the text is not correct. If you added the CSS property overflow with a value of visible to our SVG, you would see that the shape text is actually resting on top of our element. We want our text to be positioned correctly, so to do that we can provide an X and Y position which is half the width and height, so let's do that. So first we have an X value of 25, and then we can just copy and paste this. So we can change it to a Y value also of 25. So you can see on the live preview that the position of the text has updated, but it's still not exactly what we want, so let's try to address that. So if we look at the shape, you can see that the text seems to begin in the middle on the x-axis. This actually corresponds to the x value that we have provided, 25, so it's working as expected. The default anchor position of text has a value of start, so this is why the text begins here. So we can update this with the property text anchor and then give it a value of middle. So if we save that, you can see that the text has updated and it's now in the correct position that we would like on the x-axis. The text is starting to look better now, so if we address one more issue, and that's the position of the text on the maybe y-axis. So if we use the SVG attribute dominant baseline and then give it a value of central and save the file, you can see on the live preview that now the text is positioned as we wanted. And lastly, we can also provide a fill value. So the default value is black, so this won't provide any change. We can just state it explicitly. So if you want to change the color, you can use this fill value for the text. You'll notice that the SVG rect element is touching this heading slightly, so it doesn't look so good. The SVG acts as a container, and our shape element currently doesn't have a position, so it's at the coordinates of 0 and 0 with x and y. So it's at the very top left position in our SVG. So if we apply some transform, we can address this, and we can give it a value of translate and the coordinates are 50 and 50. In the live preview, you can see that the rect element has now been positioned at the coordinates x and y of 50. Unlike the text element, which can use x and y to create the position, the G element in SVG doesn't support an x and y attribute, so that's why we are using a transform for position here. This will hopefully give you a good idea of how to create shapes on your own in SVG. The next step is to create this same shape in JointJS and find out if it's a complicated process or not. So let's find out. In order to get started with JointJS, we will update the script in our HTML. And we can open the relevant file and explain a little bit what's going on too. So once again, we begin with the blank canvas in our live preview with the aim of walking you through the whole process of creating a JointJS shape from scratch. And remember, we are making that same shape that we've looked at already, a simple rectangle with the centralized label. To create an element from scratch, we can inherit from the default element class by utilizing its define method. So we can copy the basic boilerplate of creating an element here. So we will provide the define method with 3 parameters, a type, which is the name of our subclass, an empty object, which will contain our properties, and lastly, an object which will contain our markup. So once we have the boilerplate or basic boilerplate created, we can add the shape to our namespace, so we can get that over with now. So our properties object can contain numerous things. It could contain size, position, general attributes, but first we will focus on the markup in the third parameter. So the markup will contain the SVG elements that make up our shape. A beautiful thing about JointJS is that when utilizing this SVG utility, you can see here, you can more or less copy the same markup from our first example right into your JointJS shape definition. So if we copy this rect and text element, we can paste it right into here. So you'll immediately probably notice a few differences with the JointJS shape. The first is this XML comment here. So this basically tells our code editor that this is XML and gives us this nice syntax highlighting in the markup. So if you delete this comment, you can see that the syntax highlighting disappears, so we will put it back. The second thing you'll notice is that we don't have a group element or a G tag to group all of our elements together. The reason for this is JointJS actually takes care of this for you under the hood and creates your elements within a group element. Now that we have provided the markup for our shape, it's actually possible to add the shape to our diagram. So first we can uncomment this code at the bottom to create our shape, and then we can add the shape to the graph. So when we save the file, you can see the shape appears on the live preview. If you look at this example in our live preview, you'll notice that, like our earlier example, currently our JointJS shape is touching this heading, which doesn't look so good, and it's for the same reason that our JointJS shape is currently at the coordinates 0, 0 in the top left of our SVG. So in our markup, we don't have the group element. So in JointJS, we provide a position value in the second properties parameter. And if we save this, you can see that the JointJS element has now changed position. And under the hood, it's the exact same. There's a group element with a transform and translate applied, just the same as our first example. And because we are using JointJS, we can already move this element around the paper. All in all, it's quite a straightforward process to create an equivalent shape, and now we have a good base knowledge of how to create shapes from scratch with JointJS. So now we can take a step back and look at our first example with the SVG markup one more time. So currently the SVG looks exactly how we want it, but what if our label contains multiple lines of text? How would we display this? When working with SVG, you'll soon discover that working with text is a little more complicated than HTML. Text editing and simple alignment can be a little bit trickier. To get started with our second shape, we will just copy and paste the existing shape that we have here. And we can also adjust the transform a small bit and save the file just so we can see it on the live preview too. And we want some placeholder text for our multiple line labels. So we will create the text of John Doe. And once we save that file, we can see that the width of the text is now greater than the width of the rect element. So we will have to take care of this too. To get our text into multiple lines, we are going to use an SVG element called tspan. So this will allow us to divide our text into subtext, so we can do this now. You may have been expecting once we created the tspan elements that the text would appear on multiple lines, but that's not the case. But the behavior is what we would expect. So we have an x value of 25 and the text anchor is in the middle. So that's what we see here. So if you want to change the position of a tspan element, you actually have to apply the positional value independently to see some results. So if we apply some x value of 25 here, and save the file, we can see what happens. So now you can see in the live preview that both text or both tspans are actually now on top of each other. And this is what you would expect to happen because the tspan has an x value of 25 and text anchor of middle, and this applies to both of them. It would be nice if this nice dominant baseline attribute spaced or positioned the tspan elements in a way that was understandable, but that's unfortunately not the case, but it is working as expected. So to change the position of these tspan elements or subtext elements, we actually have to apply some white positions to change the text vertically ourselves. So first we can adjust the y value of the text element and give it a value of 18. Then we can use a dy attribute to change the value of the tspan element vertically, and we can give it a value of 1.2 rem and save the file. So now on the live preview you can see we have a nice rectangle with the multi-line label. Just to review a few of the attributes one more time, the dominant baseline attribute is applied on the text element only, so it won't position multiple lines of text independently. On the second tspan element, we use the dy attribute to position the text vertically. This positions the text from the previous tspan, but it would also be possible just to use the y attribute here. We also use a CSS unit rem for our dy value. Here it's also possible to use different CSS units like m or pixels. You can still state px for pixels explicitly, but if you don't use it, it will still be pixel units. We have created our second shape in SVG markup, so we can try to create the second shape or the same shape in JointJS. So let's get started with that. And we'll also look at some interesting features that JointJS provides. To get started with the same shape in JointJS, we will copy and paste this shape definition just to act as a boilerplate for the new shape. So we can change the name of the shape to shape2, also update the type of the shape to shape2. Regarding the position, we can update the X position to 150. And lastly, we can look at this text element here. So we can remove the dominant baseline. We can also remove the closing tag and the text itself. And we will make this text element a self-closing tag. Then we can add the shape2 to our namespace. And lastly, we can create shape2 and add it to our graph. So once we save the file, you can see that this has updated on the live preview. The process of creating this second shape in JointJS is a little bit easier, and we look at some interesting features that JointJS provides. If you look at the live preview, you'll see that our element is currently missing some text, and that's the main aim of this element, to create this multi-line label. So let's get started with that. We can introduce one interesting feature of JointJS, and that's selectors. So let's first create one. So here we have an @ symbol and the word selector, and we give this a value of label. So here we are talking about a text, so the value for selector is semantically chosen. You can think of selectors in a similar manner to CSS selectors, in that it allows you to target some element and apply some rules to it. The selector value label will correspond to a property in our attributes object. This is denoted as attrs for short. So let's create this attributes object. So here we have a label which corresponds to the selector, and we have a text property in our label too. So currently this is an empty string, and we want to have a multi-line text, so we will create our text of John Doe. So once we save the file, again you can see we have the text of John Doe, which has a wider width than the width of our rectangle. Currently our text is on a single line, so to adapt this in JointJS we can add a new line character to our text value, and if we save the file you can see that this is updated to multiple lines in the live preview. So under the hood, JointJS is actually creating these T-span elements, so this is why we don't have to create any T-span here in our markup. When we save the file, you'll notice that JointJS also adjusted the Y value of this second T-span element under the hood, so this is something we don't have to worry about in JointJS 2. You will notice that the text is not centered perfectly. So JointJS does have some special attributes. It is a superset of SVG, and it allows you extend the language with some attributes, and we will provide a link to the attributes in the video description. So let's try to use one of those attributes, and that is text vertical anchor with a value of middle. So if we save this file, you can see that the text updates nicely. It's now nicely centralized, and that basically completes this second shape in JointJS. In our JointJS example shapes, we are still hard-coding values for properties like width and height. So this works, but it would be better if we could create some template. And this is one of the main advantages of JointJS. It allows us to create these shape templates, provide the element with some width and height, and JointJS will work out what the size of the element and sub-elements should be. So how do we go about doing this? To get started with more template-like shapes, we can use the calc function which JointJS provides. If you are familiar with CSS calc function, it functions in a similar manner in that it allows you to perform some calculations. In our case, we perform calculations when specifying SVG attribute values, and in JointJS we are performing these calculations on model data. Calc allows elements to be a dynamic template, enabling users to create many instances of an element and provide different widths and heights to each instance, while having each element and its sub-elements adjust relatively to the provided sizing. So this is really powerful. We can try to apply calc to this shape number too. So to get started, we will delete some of the hard-coded values. So x and y is deleted from the text element, and width and height is deleted from the rect. We will also add a selector here, and we will give this selector a value of body. Now that we have created this selector with a value of body, we can target this element with some rules in our attributes. So we will supply a body property with a width and height, and these width and height values will have a value of calc equal to its width and height. So it might seem a little bit strange at first, but you will get used to it very quickly. And remember, we also want to provide an x and y value to our label, which will be half our width and height. So we can copy and paste this and change the width to x and change the height to y. So here we are going to do something interesting. We are going to take advantage of some division using calc, and we will divide the width by 2 and the height by 2. And that means that it will equate to our value 25, which we had earlier in the end. Upon saving the file, you'll notice that our rectangle has now disappeared and we have a small black square. This is simply because we haven't provided width and height yet, so JointJS defaults to a width and height of 1 pixel, which is why we can see this small square here. Now we have our width and height and x and y value set up with calc, so calc allows our shape template to be dynamic. So we will provide our width and height values in the constructor, and as our x and y is based on our width and height, we actually don't need to provide an x and y value for the label, which we will see in a moment. So in our shape2 constructor, we will create it with a size property, and then we will use the width and height values from earlier, which was 50 for each. So if we save the file on the live preview, you can see that we have our shape from earlier, and because the label values are based on the width and height, we actually don't need to provide the x and y values for that. So that's really powerful. Along with the size, position, and general attributes, you could also update the rotation of an individual instance with the angle property. So let's see how that looks. So upon saving the file, you can see that shape2 has updated here. There's also a rotate method which achieves the same thing, so we can go ahead and remove this property once more. Just to illustrate that this is really dynamic, we can resize our shape2. So JointJS provides a resize method, and it takes a width and height value. So we will just double the size of our element, so we will change it to 100 and 100. And if we save the file, you can see that this is updated in our live preview. And the great thing about this is that the label is still in the correct position because it is based on half of the width and height. So we have provided a width and height of 100 in this resize method. So now the x and y value of our label is at 50. So this is a really great thing about JointJS, and it really shows that these shapes can be dynamic when using calc. As you gain more experience with JointJS, you will understand which elements you want to add a selector to. If an element needs to be dynamic in some manner, or you want to use special attributes and values like text vertical anchor or the calc function, those are always good candidates for using selectors and attribute properties. A lot can be accomplished with these basic SVG elements, such as rect, which we have looked at already. But if you wanted to add some slight iteration to a shape, such as a beveled or a clipped corner, utilizing the rect element in this instance is maybe not ideal, and a good alternative would be to use an SVG path element instead. This allows you to visually present a shape as a rect with a bevel corner, but under the hood it's an SVG path element. So we can take a look at applying this in the original SVG file. So we will use the first SVG shape as a template, so we will copy it and paste it below. And we will also change the transform of the y to 150. So once you save the file, you can see the third shape in the updated live preview. The aim of this third shape is to introduce the SVG path element, so we will copy and paste the path element instead of the rect. So if we save the file, you can see that the shape is updated and now it has this beveled or clipped corner, but it still appears like a rect element. The path element is one of the most powerful SVG elements. It allows you to create some very complex shapes, not only kind of rects with some iteration, but you could create some lines, some arcs, and so on. It's made up of a D attribute with a series of commands. You have some letters denoting line commands like move to or line, vertical, horizontal, and you also have some numbers which correspond to parameters like x and y values. If you want to learn how to create some line commands, we will link a good article in the description of this video. As with previous SVG examples, we're also going to create the same shape in JointJS. We won't spend too long creating this shape. We're just going to copy and paste the shape definition and then we can study it for a moment. So here we have the size property, which contains a width and height of 50. Then we have our x and y values for our label, which uses the calc function. And remember, these are half this width and height, so the label will be positioned in the middle. And lastly, we have the same path element that we used in the last SVG example. If we try to resize this element as we did with shape 2, it wouldn't be totally responsive as our path element coordinates are currently hard-coded. So we will look how to address this in our final shape. Now we just have to add shape 3 to our namespace so we can update that here. And lastly, we can add the shape to our diagram so we can uncomment this code here. Now you can see on the updated live preview, we have the exact same shape from our SVG example. This time we're going to create a few instances of this shape, and you may have noticed that we didn't create a position property on our shape template. That's because we want each instance to have a different position. So let's see how that looks. So first we are going to use the position method on our first instance and save the file. So now you can see this has updated in the live preview. To make another instance, we are going to use the clone method. This creates an instance with identical properties and then we can add it to the graph. So after saving the file, it doesn't look like as if there have been any changes. That's because our clone is currently overlapping the original instance as it also has the same position. To update the position of the second instance, we are going to use the translate method. The position of the first instance on the x value is 50, so we will translate this by 100 and save the file. So now you can see both instances in the live preview. Just to illustrate that these templates or shape instances are dynamic, we can maybe update one of the attributes. So if we look at the second instance, we can try and update the text color. So earlier you can remember that we created a selector with a value of label. So here we target the fill of this label and give it a color. So if we save this file, you can see that the second instance color has updated here. Now we've created 3 shapes in JointJS and SVG. So we're going to create one more complicated shape in SVG. So if we return to the original file, we can copy and paste the last SVG shape here and save the file. Now that we have saved the file, you can see the updated live preview. So it kind of looks like a SIM card, and now we have this image in our shape too. This SVG element is pretty similar to what we have looked at already. So again, we have our path element, which contains the D attribute and line commands. We also have an image tag, which is newly created in this shape. So it has similar attributes which you would expect from an image tag. Just one note, you will notice the image tag is slightly different than the HTML image tag. So in HTML, the tag is img, so it's a little bit different. Lastly, we have the text element, which contains these sub-element T-spans, and this is the same as an earlier shape we looked at in SVG. One point you'll immediately notice about this last SVG shape is it's slightly more difficult just to read. The hard-coded values in the SVG start to get more complicated rather quickly. Margins between elements have to be calculated correctly, and it's probably not that flexible in terms of resizing. So this is all well and good for SVG markup, but again we want our shapes to function as templates and adjust its size automatically. That means one last time we can return to the JointJS elements so we can update this script. And we can copy and paste the last shape just to save ourselves some time. Before discussing the shape in more detail, we will go through the same procedure as before. So first we will add the shape to our namespace, and then we can add the shape to the graph. And you can see once we save the file, we have this updated SIM card-like shape in the live preview. You'll notice a lot of uses of the calc function here, and that's the real star of the show. So earlier we used the calc function with width and height variables, but looking at the text property, you can see that we used calc with an S variable. So this stands for the shortest side of the rectangle. If you would like to see other variables you can use calc with, you can take a look at our documentation. So here we have x and y variables, the shortest, longest side of the rectangle, and also the width and height, which we mentioned earlier too. So you can see there are quite lots of variables you can use calc with, so it's quite flexible in this manner. Just to speak about calc a little bit more, we can focus on the text property. This property corresponds to the John Doe text on the fourth shape. So here we use the calc function with the S variable. So this, remember, stands for shortest side of the rectangle. And above we can see that the size is width and height of 150. So the shortest side of the rectangle is 50. So this x value will equal 50. So that's why this text begins in the middle of the shape. We can also look at our image property. So here we have a width and height that is using the calc function. So remember the S variable here corresponds to 50. So for the width and height, it's 50 minus 20, which means our image has a width and height of 30. Taking a look at the body property, you can also see that we are using the calc function within this D attribute. So even for pat elements, we can take advantage of calc. So this really allows our templates or shape definitions to be dynamic and to do relative sizing and so on. So one feature of calc is you don't have to worry about the values becoming negative. JointJS will take care of this for you. It's also possible to nest uses of calc, so taking all of these things together, it's a really powerful feature when working with JointJS. Lastly, again, you can see that our shape is in the incorrect place, so we will take advantage of the position method once more to update the coordinates. So if we call the position method with the updated coordinates and save the file, you can see that it looks much better now. Just to show how effective the calc function is when using it in the pat command of our element, we can resize the element and also remove the new line character from the text value so it appears on one line. Saving the file, you can see that the sizing has adapted correctly, demonstrating just how useful it is to use calc in combination with your shape templates. We could also test adding a JointJS resize tool to this shape, so we have a demo demonstrating the resize tool in JointJS. So we will copy and paste the resize tool to our own demo and try to add it to this shape 4 that we have. Resizing the shape, you can see the power of using calc with different variables. and that the text maintains the position we want. If you want some responsive text, JointJS also provides a special text wrap attribute that you can take advantage of, so that's something to remember too. You can find out more about the features mentioned in our documentation, and remember to check out the links in the video description below, including that MDN SVG attributes reference. So that's everything we will talk about today. I hope you found it helpful, so thanks for watching.